creating equations standard .4, right? That's the CED for algebra. We're going to do some rewriting and equations, equations and formulas. We're going to rewrite them in a multitude of different ways. So let's get going. Let's try this out. Okay, first one. D equals RT. This is a pretty basic, I shouldn't say basic, but it's a pretty common formula that we use all the time. D is distance, right? In whatever unit you choose. R is the rate, and T is the time. So to find the distance of something, right, I can figure out the rate, how fast I'm moving or how fast something is moving, and multiply it by the time. So for instance, let's say you're driving at 50 miles an hour and you travel for 2 hours. What's your distance? We can multiply the rate, 50 times 2 hours will give you a distance of 100 miles, right? That's one way of doing it. Well, let's say you know the distance and you know the time and you want to find the rate. So what we're going to do is we're going to solve for r. So I'm going to rewrite this thing so that it's going to end up looking like r is equal to something, right? So if I look at this and I have r multiplied by t, in order to figure out what r is, I'm going to divide both sides by t. So I'm going to divide this side by t, and I'm going to divide this side by t, and the t's on this side, time cancels itself out, and I'm going to get that r is equal to the distance divided by the time, which if you think about it, the rate, right, the speed of which I'm traveling in this case is going to be the distance, let's say 100 miles over 2 hours. When you simplify that, that's 50 miles per hour. That's what rate is, okay? It's the distance divided by the time. Or really what you're doing, it's a ratio. You're comparing how far you travel to the amount of time it takes you to travel that, and then you turn it into what's known as a unit rate, meaning if I was only in one of these, 1 hour, how far would I go? Okay, and that's why I use it as a comparison. So then the rate is equal to the distance divided by the time. Okay, well, let's do the same thing. Let's say I want to solve it for t. I want to know what t is equal to, right? How do I find that? Well, I get distance is equal to the rate times the time. And in this case, I'm going to divide by the rate on both of them. Okay, so the time is going to be equal to how far I go divided by how fast I was going to get there. Okay, and so now I've solved these of all different ways, and it depending on which one I want. If I want to know the rate, I'm going to use this equation. If I need to know the distance, I'd use this equation. If I want to know the time, I'm going to use this equation. Okay, and that's the general idea. So let's try it again. Let's try another one. Perimeter. Perimeter is a thing we use oftentimes. This is when I add all 3 of the sides of a triangle here, or if it's quadrilateral, I'll just add 4 sides. But you add them all up to get the perimeter, right? Side 1 plus side 2 plus side 3 will give me the perimeter of a triangle. Well, what if I want to find the side? What if I know the perimeter in 2 sides and I want to find the extra side? Let's say I want to find side 2, okay? How long is side 2? I want to solve this for side 2. So I can say, all right, well, in order to get to side 2, all right, I'm gonna subtract side 3 from both sides, right? So subtract side 3, and then I'm also going to, well, let's just go ahead and we'll do it step by step. I'm gonna get, that means I'm left with side 1 plus side 2 is equal to the perimeter minus side 3, right? And then I can subtract side 1, right? This little sub, see how it's a sub number? So that's describing the side. So S would be side, and then this is the 1, right? First side, second side, third side, okay? Not to be confused, if it was, up here, then it would be an exponent, okay? Which would be repeated multiplication. This is it's sort of a label of your variable. Okay, so subtract another S from both sides, and I cannot subtract S3 and S1. I don't know if they're the same or not, so I can't do anything with those. Okay, so then in order to find S2, I'm going to take the perimeter and I'm going to subtract side 3 and subtract side 1. Okay, that's one way to do it. Another way I could write this, okay, is if I knew the perimeter, right, I can subtract side 1 and side 3. Okay? Notice how I said that. I said it a little differently. If I know the perimeter, I can subtract side 1 and side 3. Okay? So I can figure out how long is side 1 and how long is side 3, put them together, and then I subtract that from the perimeter. Okay? It's the same idea. Okay. Moving on. Here's just a generic formula. AX plus B is equal to C. All right. Let's go ahead and let's solve this for X. So I want to know, we're going to solve this, all right, for X. All right, well, let's see. What are we doing to X here? If I've got X and I'm multiplying it by some number A, and then I'm adding some number B, and I end up with some number C, okay? So if I knew what these numbers were, right, the first thing I would do is I would subtract whatever that number is, right, or I'd do the additive inverse here. So I'm going to do the same thing to that side, and I'm going to end up with AX, okay? The B's cancel each other out, and then I'm going to get C minus B. Okay. Well, this is kind of like that perimeter problem we just did, right? Subtract that. And then, in order to get, right, that means AX is equal to C minus B. And then in order to find X here, whatever A is, right, if this was 2X, I would divide by 2. If this was 3X, I would divide by 3. If it was 85X, I would divide by 85. So I'm going to divide by whatever that number is. And then I have to divide that whole thing by the number. So I get X is equal to C minus B over A. Okay. Or I could write it also as, and this might be a better way of doing it, is I'm going to take C and then I'm going to, whatever B is, I'm going to make it the opposite. Okay? All right, hopefully that makes sense. I want to show you just one other way. This is sort of a way that I learned when I was in school. Some people like this. This is the vertical method, right? This is a lot more popular and sort of what I've seen so far is when people teach this. Sort of another way you can do this, and it's the same principle, okay? It's the same idea of both sides. Sometimes students find that this is a little easier. Or more confused, it just depends. So if I have AX and I want to get rid of B, right? So if I have B, then the opposite of that is, right? I'm going to do the opposite. So I add B, so then I'm going to add negative B. And that's going to equal C plus negative B. Okay, now notice this here is the same as there. So I'm doing the same thing to both sides, which is this same step. Okay? This one is just horizontal. And then what you can do is you can say, all right, AX plus B plus the opposite of B, well, that just turns into AX. And then I have C plus negative B. Okay. Again, divide by A, and you end up with C plus negative B over A. And if it helps you, might want to put those in parentheses. Okay. Moving on. Let's try another one here. Why don't you try solving, let's do this. Why don't you pause the video, solve it for X and for Y. Okay, solve it for X and then another, and then solve it for Y. So we'll do down the middle here. Solve for X and then solve for Y. Okay, this side, solve for X. And over here, solve for Y. All right, go ahead. All right, I'm going to go ahead and do, so I have 3x plus 2y is equal to 8. So first thing I'm going to do, I have 3x. I'm solving for x. I want to get rid of this y. How do I get rid of it? I want it to go to 0, so I'm going to do the additive inverse. Okay, so that's a negative 2y and a negative 2y. Now, let me actually erase this. I typically like to put, since this is a constant term and this is a variable term, I like to kind of put it off to the side just to keep myself so that I don't add these two, because I can't put 8 and negative 2y together. I mean, I can't combine it to make like 6y or 6. That doesn't work. So I'm going to end up with 3x is equal to 8 minus 2y. Then I'm going to divide by 3. Divide both sides by 3, and I'm going to end up with x is 8 minus 2y all divided by 3. And that's solving for x. All right, well now let's go ahead and let's solve for y. So I've got 3x plus 2y is equal to 8. And again, I'm going to say, all right, this is hanging out over here, right? I'm adding this, and I want it to go away. So I'm going to add the inverse. Okay, and then I'm going to say, okay, combine those, and I get 2y is equal, again, notice I put it sort of off to the side here. I didn't want it to combine there. So I got 8 minus 3x. Okay, and then I'm going to divide this by 2, divide that by 2. Everything gets divided by 2, and so I get 8y is equal to 8 minus 3x, right? All of this divided by 2. Now, another way we could have done this, right, and written this step. Whoa, that was way more than I wanted it to fall away. Let's grab this. I just want to move this over to the side. Now, what we could have done here is when you divide it by 2, right, we could have said, whoops, that's not what I want. What I could have done is I could have divided each thing by 2, right? So everything by 2. So I could have said, or I could say y is equal to, and then 4 divided by 2, or 8 divided by 2 is 4, and then minus 3x over 2. Okay? These are the same things, same ideas. Okay? All right, hopefully it makes more sense. We'll do one last one here. This is when you have, this should look familiar. This is taking Celsius, right, or taking a Fahrenheit temperature and turning it into Celsius. What I want you to do is I want you to rewrite this so that you can figure out how to find Fahrenheit temperature if you know Celsius. Okay, so this is the generic way. If you know the Fahrenheit temperature, you plug it into here. You find the temperature in Celsius. I want to know, what does this thing look like if I make it F equals? So that means I can change the Celsius temperature and convert it back into Fahrenheit. So why don't you go ahead, pause the video and go ahead and do trying it now. All right, I'm going to rewrite this equation. So I'm going to say 5/9 times F is minus 32. Now, one thing I could do is I could do the distributive property, okay? But I'm not really going to want to do this because I have this multiplication problem, right? 5/9. So there's two ways. I could do this in 2 steps. I could multiply by 9 and then divide by 5, or I could use my additive inverse, right? So I'm going to multiply this side by 9/5, which means I need to multiply this side by 9/5. And what I'm left with here is I've got 9/5, right, times C is equal to, right, well, this 5 and 5 cancel out, 9 and 9 cancel out, so I'm left with Fahrenheit minus 32. Okay. Well, then what I'm going to do is I'm going to go ahead and I'm going to just add 32 to both sides. Okay, and I'm going to add it off to the side here so I don't get it confused. We'll combine those, and I'm going to get 9/5 Celsius plus 32 is equal to Fahrenheit. And there we have it. And if you, let's say you don't like the 9/5. See, another way you could write this is 9C over 5 plus 32 is equal to Fahrenheit. Maybe that helps out a little bit more because you look at that and you say, okay, well, I take the Celsius, multiply by 9, and then divide by 5. Okay? Or you could do 9 divided by 5 and then multiply by Celsius. It doesn't really matter. When you multiply and divide, the order doesn't matter. Okay, hopefully you have a general idea on how to do that. You're feeling a little bit better about it, and we'll do a lot of more practice tomorrow. All right, thanks.